You're live. Do not swear. Okay. So PowerPoint statistics 2, which I will put up as well, but I think it's. Oh. One. Okay, people, the normal distribution. Shh. Right, so it's data is symmetrical distributed with no skew. So basically, if you start off with a histogram, it is, these are all the same width by the way, it is perfectly symmetrical. Okay, so starting off with a histogram, it's perfectly symmetrical. Okay, and if you put a curve across it, it's called your normal curve. Okay, so normal, and most surveys fit into this, right? There's always an exception, right? Okay, but most surveys fit into a normal distribution, and if it fits into a normal distribution, girls, we can do lots of calculations on it, which is the whole point of inferential statistics. Okay, so if it fits into a normal distribution, there's lots of formulas and calculations we can do, right? Okay, to take the results of our survey and make them true to life, if you know what I mean, right? Okay, adapt them so that they fit to the population as opposed to just the people you surveyed. Okay, yeah. Anyhow, listen, if I can draw it, you can draw it. Okay, ready? No. Yeah? Yeah? Well, if Louise is ready, let's move on. I'm joking. Okay, next sentence. When plotted on the graph, the data follows a bell shape, okay? So basically, we don't need to draw the histogram anymore. We're just going to draw the normal distribution, okay? Clusters around the central region tapering off as they go further from the center. It's perfectly symmetrical around, that's the axis of symmetry. So if it's a normal distribution, it's perfectly symmetrical around that. And that number right here on the x-axis, whatever that number is, that's the mean. It's also the median, and it's also the mode of the data. Okay, so remember there'll be numbers on this x-axis because this x-axis represents height, IQ, results in a maths test. Okay, so there'll be numbers on the x-axis, right, and there'll be numbers on the y-axis. On the y-axis, it's the number of people. number of people. So if it was the maths test, this is the low mark, so this is 5%, we'll say. Very few people got 5%. Most people got 50%, and very few people got 95%. Is that okay? So most people were clustered around the middle. Normal distribution. Okay? And as I say, most surveys, right, there's always an exception, most surveys fall into this, right? And the reason for a normal distribution is, and we can do lots of calculations on a normal distribution, to take the results from our survey and apply it to a population, okay, and make it accurate, okay. Okay, are we ready? Okay, next slide. Right, okay, bit of writing here. All kinds of variables in natural and social sciences are normally or approximately normally distributed. Right, for example, height, birth weight, reading ability, job satisfaction are just some examples. Right, so they're just, most surveys you do will fit a normal curve. Okay, more will fit than will not fit, okay? And they just give you a few examples. Height, birth weight of babies, very few teensy babies, very few huge babies. Everyone's in around the middle, around 7-8 pounds, aren't they? Right, most babies are in around there. Many statistical tests, that should be tests plural, are designed, right, for normally distributed populations. As in, we've lots of formulas going forward. We're going to have lots of formulas that we can apply to normally distributed populations. Normally, a survey that says it's normally distributed, the results were normally distributed. Okay, so we've lots of formulas going forward, right, that we can apply to a normally distributed survey, right? In normal distributions, we've already said the mean, median and mode are exactly the same and they're in the middle, right? The distribution is symmetric about the mean, so the mean is exactly in the middle and is perfectly symmetrical. Half the values are below the mean, half the values are above the mean. As in, half the people surveyed will fall in the bottom half of the curve, and the other half of the people surveyed will fall in the top half of the curve. Exactly, right? It's perfectly symmetrical, okay? The distribution can be described by two values, the mean and the standard deviation, okay? So the mean is where the middle is, right? Puts a number on where the middle of the curve is, right? Okay, so the mean is a number. So if I just go back, right, that mean, we'll have that number right there, right, okay, we'll have that number right there, right, okay, so it'll tell you where the middle of the curve is, right, and what will the standard deviation tell you? Bo said it yesterday. What will the standard deviation tell you? How spread out it is. So it's always going to be bell-shaped, but sometimes it might be very flat bell-shaped, sometimes it might be a very steep bell shape. And it's the standard deviation that tells you which one it is, right? So the bigger the standard deviation, the flatter the bell curve. The smaller the standard deviation, the more squashed in together the bell curve is. But it's still a normal distribution, it's still the same basic shape, it's just narrower. So the mean will tell you where the middle is. So you'll have a number for where the middle is, right? And the standard deviation will tell you how spread out it is. Okay, so there are two really important numbers. Okay, so when we were doing statistics 1, we were learnt about the mean, the mode, the median. The mode and the median, a little bit redundant now. We're not going to talk about them ever again in this chapter, right? We talked about, for the measures of spread, we talked about range, interquartile range and standard deviation. Standard deviation is the gold standard. It's the one we're going to use going forward. Okay, right? And remember, girls, we have Greek letters. So mu, it stands for the mean, right? Okay. And does anyone remember which one stands for the standard deviation? Sigma. So it's like a 0 with a line across the top of it, as opposed to a line through the middle of it. So it's a 0 with a line across the top, right? Okay. And that stands for standard deviation, ST. Is that okay? I think I have a slide further on. There's lots of symbols, right, further on. Okay, but for the moment, mu stands for the mean, right, and sigma stands for the standard deviation. And you don't need to remember the Greek names of them, you just need to remember what they look like. Is that right? So the mean gives you a number for the middle. Standard deviation will tell you how spread out it is. Is it peaked, really peaked, or is it really flat curve? Okay, so the bigger the standard deviation, the flatter the curve. Okay, but they still all have the same basic shape. Start low, up, and it finish low. And they're all 100% symmetrical. Okay, so 50% of the people are below the mean, 50% of the people in the survey are above the mean. Okay, is that right? We all ready to move on? Right, we're moving on to the empirical rule. We're not, we're moving on to a blank sheet. No, we're moving on to an empirical rule, right? Okay, this is just numbers, write it down and then we'll talk about it. Okay? Now, those three numbers, 68%, 95% and 99.7% have to be remembered. Okay? They're not in the log tables and they're really important and they have to be remembered. So 65, 98, 99. Right? And I'll show you the diagram and what I mean in a minute. Okay, so I'll explain in 2 minutes when you have it written down. So as I say, those three percentages need to be remembered. They're not written anywhere in the log tables, and they do come up, right? And they're also come up on the ordinary level papers. So, right, if ordinary level students can remember them, so can ye. Yes? Are we good? Yeah? Joan, you're okay? Yeah? Actually, you're not writing. You're all finished. Are you back now? Are you still writing? Okay. All okay? Right, moving on. Right, this is what this means. Right, okay? So if you just listen to me for a minute. Right? So the standard deviation, girls, is the size of the steps. I'm going to be talking about steps. Right? So the standard deviation is the size of the steps. So it differs for every curve. So the size of the steps, right, that I'm going to be talking about in a minute, differ for every curve, because the standard deviation is how big the step is, right? So I'm going to say, instead of standard deviation, I'm going to say step. So in one, right, I'll talk first and then I'll go on. Right, so the mean is always in the middle, okay? So the mean is always in the middle, right? Okay, so if you go one standard deviation down, right, okay, and one standard deviation up, right, so the standard deviation will differ for every survey. So it's like one step down and one step up. You will find that 68% of the people who did the survey, their answers will fall in there, okay? Right? So if I was surveying the heights of people, right, okay, and we'll say the average height of people is 150 centimetres, okay, that's very small, but we'll say the mean is 150 centimetres, and we'll say the standard deviation mu, why am I writing with my left hand? I'm trying to be ambidextrous, but sometimes I forget that the left hand is pretty shocking. Right, okay, right, so sigma, standard deviation, is 10 centimetres. Okay, so basically I did a survey, right? I got the heights of everybody in the survey, right? Okay, I worked out that the mean was 150 centimetres, right? It was a lovely survey. It worked out exactly at 150 centimetres. I worked out the standard deviation. The standard deviation turned out to be 10, right? So I know the mean is exactly in the middle. So that point exactly in the middle is 150, right? When I say one step down, I mean if I go down 10 centimetres and I go up 10 centimetres. So that means if I go down to 140 and up to 160, so I can say that 68% of the people I surveyed, right, have a height between 140 and 160. Okay, right? If I go down 2 standard deviations, so what would I be gone? If I go down another standard deviation, what number am I gone down to? If I go down another 10, I'll be gone down to 130. And if I go up another standard deviation, what am I gone up to? 170. And what can I say about my survey? I can say that 95% of the people I surveyed had a height between 130 and 170. And if I go down 3 standard deviations, right, okay, so if I go down another standard deviation, where am I at now? 120, and I go up another standard deviation, I'm up to on 180. What can I say? 99.7% of the people I surveyed had a height between 120 and 180 centimetres. Okay, right, different survey, right, okay, exact same graph, right, different survey, exact same graph. This time I'm going to survey wait now, let's see what I survey. Give me something to survey. Maths test. Results in a maths test. Okay, so I surveyed everyone's maths test, and the mean was 67%. Okay, so that means half the class got more than 67%, half the class got less than 67%. Right, I also had my list of marks, so I put them into the calculator and I calculated my standard deviation, and we're going to say the standard deviation this time is 4, right? So the standard deviation turned out to be 4. So most people were squashed together because that's quite small standard deviation, isn't it? So where will I find 68% of people between, if 67 is in the middle, right, where will I find 68%? So I go down one step, what would that be? 63, go up one step, and I'll be up to 71. So what does the empirical rule tell me? That 68% of the class got between 63 and 71, right? If I go down another standard deviation, this time the standard deviation is 4, so I'm gone down to 59%, aren't I? Right? And I'm gone up to 75%, would you agree? And what statement can I say now? 95% of the class got between 59 and 75. And the last one, I won't write it down. What would it be? Down one more step, what would that be? 55, up one more step, what would that be? 79. So I can say 99.7% of the class got between 55 and 79%. Is that okay? And that's what the empirical rule tells us. Those 68, 95, 99.7 never change, right? If it's a normally distributed survey, which most of them are, and if it's not, they'll tell you, right? If it's not normally distributed, they won't ask you anything about it because there's no rules for things that aren't normally distributed. Does that make sense? And does that whole one step down, one step up? The step is the standard deviation, the step is the standard deviation, right? It'll change for every survey, right? The mean will change for every survey. The shape will change. Sometimes it'll be really narrow, sometimes it'll be more spread out, right? But it'll still be one step up, one step down, 68%. 2 steps up, 2 steps down, 95%. 3 steps up, 3 steps down, 99.7%. Okay, and as I say, you have to remember those numbers. They are not written anywhere, so they must be written in here somewhere. Okay, and it's, what's that rule called? Empirical rule, right? Okay, so how am I going? 10:02. Yeah, I've time for an exam. Do you wanna write that down? I'm not sure about put in all the percentages, because they've it all broken down for you, right? Do you know that of that 68, 34 is above the mean, 34 is below the mean. Of the 95, half of 95 is, what's half of 95? 45.5. No, it's not. 44.5. No, it's not. 49.5, thank you. Right. Half of 95 is 49.5. So look, 34, it's actually 47.5, right? 34 and 13.5 add to 47.5. So for 2 steps down, there's 47 at each side, 47.5 at each side of the mean, right? Okay, and
excuse me, please, will Amy and Swan go to the library at 10 past 10, please? Amy and Swan. And would Jessica EK come to reception at the bell also?
So are you trying to like describe the distribution of the two values?
Yeah, you'll see the questions in a minute, right, okay, right, but you can clearly, what I'm trying to say is that 68% is, there's 34% below the mean, 34% above the mean, right, for the 95% there's 47.5 below and 47.5 above, and you know there's 34 as far as here, so 34 and 13.5 make 47.5. So you know this little bit, the green bit is 13.5%, right? Okay, so you can play around with the numbers and get what percentage is in the different sections. Right, I've no examples done, right, okay, so I'm going to leave you have a go 1 to 5, and then come Monday, look, I have 3 examples, come Monday I've an example for us to do, right, okay, so we can write that in on Monday and see. But see what you can do with, page 299, 1 to 5, right, in the meantime, okay? So see what you can do with page 299, 1 to 5, okay? I have 4 minutes, so will I just look at the next example? We won't write it down because we won't have time to write it down, but we can talk about it, yeah? Is that okay? So has everyone got the homework written down? And we're just going to look at the example and talk about it, right, just to give us an idea of what we have. A simple no thanks would have done. Right, okay. The mean time it takes factory workers to get to a factory is 35 minutes. So we have the middle number. What's the middle number? 35. Right, the times can be modelled by a normal distribution, okay? So that means we can use the empirical rule with standard deviation of 6. So that means the steps are 6 up, 6 down, right? Okay. What percentage of workers will take between 23 and 47 minutes to get to work? So if you go 23, if you go 35, go down 6, 29, 23 is 2 steps down, isn't it? And is 47 2 steps up? Yeah, 2 steps down, 2 steps up. What percentage? 95. Lovely. What percentage will take longer than 47? So, longer than 47. What did we say 47 was? 2 steps up, isn't it? So, there's 50% here, isn't there? And there's another, what's half of 95? 47.5, wouldn't there? So that's 50 and 47.5 makes 97.5. So how many's left? 2.5. Do you know what I mean? What that means is, look, right, okay, so we know up to 35, we know that's 50, don't we? We know that's 50%, right? Up to 47, we know it's 2 standard deviations. So 2 standard deviations would be 95 on both sides. So it would be half of 95 is 47.5. So we know there's 47.5% in there. Agreed? So up as far as 47, there's 50 plus 47.5, so there's 97.5. Would you agree? Yeah? And it says, what percentage of work take longer than 47? So what's above the 47? What percentage? 2.5. Okay? Yeah, a little bit of thinking about it, right? Okay, but we'll get there. Okay, I will do that question out properly for you on Monday. Okay, is that alright?